Hey guys, welcome back for another chemistry lesson. In this video, I just wanted to do a recap of Mendeleev and the periodic law so that we could have that fresh in our minds when we're thinking about periodic trends. So, movement of ions across the cell membrane is the basis for the transmission of nerve signals in your body. And we have sodium and potassium ions that are pumped across membranes using these ion channels that they can move across. The structure of that's not really important for this, but basically we're moving sodium out and potassium in, right? And so these ion channels that allow for the movement can differentiate sodium from potassium based on the difference in size. Our ion size and other properties are periodic properties that we can predict based on the element's position in the periodic table. And we can thank Dmitry Mendeleev, who was a Russian scientist that first thought about this periodic occurrence of properties. So what he did was he took all of the atoms that they knew existed and put them in order by atomic mass. And when he did that, he saw this repeating pattern of properties. So this guy is really reactive. Well, blah, 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 blah. Well, now this guy's really reactive. Blah, blah, blah. And so he would see periodically there would be this repetition. So we call that the periodic law. When elements are arranged in order of increasing atomic mass, certain sets of properties occur periodically. This is how Mendeleev described it. So he put elements with similar properties in the same row, and he used patterns to predict the properties of elements that hadn't even been discovered yet. So where the atomic mass order didn't fit other properties, he reordered by other properties. And a notable example of this is tellurium and iodine. So this is what his periodic table looked like. We can see that fluorine, chlorine, bromine, and iodine are our halogens, and they are in the same row because they have the same property. You'll notice there are a couple of places like here and here where he put question marks because he knew that zinc did not behave the same as aluminum and neither did arsenic, so what gives, right? So he left these blank spaces and was like, well, there's got to be something that we don't know about yet that has properties similar to silicon, in this case. There's got to be something, right? So he was really, really close, right? So his predicted properties about gallium, about 68 atomic mass units, he was very close. Low melting point, you can literally melt gallium in your hand. Density of 5.9, he was right on that. How it bonds with oxygen, he was right on that. How it forms bonds with chloride, he was right on that. So he was actually really, really good in his predictions. Now, we do not currently follow Mendeleev's periodic table. You will notice that I said that his periodic table puts stuff in the same rows that have the same trends. We have now flipped it so that they're in the same columns. And there was also the change of looking at atomic number versus atomic mass. And the reason for that is because the mass is different. We have talked about in this course that our different isotopes have different masses, so that's not something super consistent and reliable to use for this. So we've made a few changes, but Mendeleev is really where it started. Right? His periodic law allows us to predict what the properties of the element will be based on its position on the table. What it doesn't do is explain why that pattern exists. And so this is where quantum mechanics comes in and explains the why, right? Knowing why allows us to predict what, even though that is a pattern that Mendeleev saw long before quantum mechanics came into play.